Flat panel power quality tester, field use method, instrument power button. 230 to communication interface, USB data export interface for plugging in a USB stick. Battery charging port inside the instrument. Voltage terminal, current terminal. Flat panel power quality testing is used to perform harmonic testing on high voltage and low voltage power lines in the field. Divided into 3-phase 3-wire. 3-phase for wire to modes. Low voltage lines of 380 volts generally use 3-phase for wire because the voltage has a neutral wire. 3-phase 3-wire is for high voltage metering lines. It is a line via PDCT. We take the voltage and current on the secondary side of PDCT. Select 3-phase 3-wire. We are now in the low voltage switchgear. Demonstrate on-site test with 3-phase and 4-wire wiring. First, connect the voltage terminals. Voltage line, yellow, green, red, blue, black. UA, UB, UC on and neutral lines for voltage lines respectively. But when we connect the wires on site, not test 0-phase voltage and 0 sequence current, so we just use yellow, green, red and black. UA, UB, UC, UN. Connect the live part at the other end. We came with an alligator clip. There are 2 kinds, one small and one large, according to the situation on site. Just choose the appropriate alligator clip and connect it. This is a simulation, so we don't need the alligator clip now. Plug directly into the UA terminal below the air switch. UB, UC, and UN terminals. There are 3 current pliers, yellow, green and red, which correspond to the IAI-BIC of the instrument respectively. If you see a gap here, match and plug it in tightly. We are directly stuck to the current line without going through CT. The current pliers have arrows on the side. The arrow direction is consistent with the actual flow direction of the current. Phase B, C phase, a phase. After connecting, enter the parameter settings. Select 3-phase for wire. Gently touch and click. Current input. We are now using small 5 amp pliers. Select 5 amps small clamp. If you choose a 500 amp medium clamp, or 2000 big amps, select the corresponding clamp meter. Voltage turn ratio. Current turn ratio refers to when high voltage metering lines pass through voltage transformers and current transformers. When we take the voltage and current signal from the secondary side, we need to set it. Our low voltage line has no PD or CT. The voltage turn ratio and the current turn ratio are set to 1. The rated voltage should be input according to the actual voltage of the line under test. We are 380 volts. Note that the unit is kilovolts. Enter 0.38. Close. Short circuit capacity is checked according to the different voltage levels of the national standard. Low voltage short circuit capacity has national standard. Unit is megavolt ampere. Note that the conversion relationship with kilovolt ampere is 1000. We find it is 10 megavolt amps from the national standard table. We will note on the manual for the national standard, which is based on the line voltage level, 10 kilovolts, 35 kilovolts, and 380 kilovolts, according to different voltage levels, have different corresponding values. Power supply capacity. This refers to the capacity of the transformer at the next higher level on the line we are testing. It refers to which transformer our line outputs from. Input that transformer capacity. Also pay attention to converting to units of megavolt amperes, kilovolt ampere and megavolt ampere conversion. Let's enter 10 megavolt amps here as an example. Take this as an example. The agreed capacity refers to the agreement on the power supply capacity of this line signed by our power user and the power supply bureau at that time. Under normal circumstances, the output of capacity and power supply capacity can be the same. Substation name. Click to pop up the text box. It can be English letters, uppercase and lowercase, or Chinese characters. Chinese is in pinyin mode. The same goes for the line name. We can edit it ourselves here. File name. When we need to monitor a line for a long time, when we store the file, we set a file name according to corresponding point of test to make later search easier. File name can be edited. 01. After setting these corresponding parameters, after setting, click Return. Enter electric parameters. At this time, we can see voltage and current angle of phase A, B phase voltage and current angle of C phase. Below is the power. You can see the various electrical parameters and if there are any abnormalities in the voltage, current and angle of each phase. This is a secondary parameter. It is the low voltage circuit we are directly setting up now. CD ratio and PD ratio are both 1. So high voltage lines and low voltage, primary parameters, are the same. If it is for high voltage line through the PD and CT, then secondary parameters are secondary parameters, and primary parameters are actual primary parameters of the line under test, and the power is the same. Then below is flicker. It is long-term flicker, and there will be short-term flicker. After we see that these parameters are normal, we can return to see harmonic testing. Harmonic test. This screen simultaneously displays the respective harmonics of the UAUB-UC3 phase voltage and the IAIB-IC3 line current. Flip down 1 to 16 times per screen, flip down 17 to 32, up to 64 times. It can be flipped up. At this time, what we see is the real-time harmonic content of each phase voltage and current of our measured line. Spectrum analysis. It is a single channel to check the harmonic content of each phase voltage and current. Here select to show each harmonic content of voltage and UA phase are represented in the form of a bar chart, which is more intuitive. It is displayed by phase separately and can click to switch UB, UC, IAIB, IC. Harmonic testing and spectrum analysis. The displayed content is the same, but in different forms. Waveform display. This is the voltage and current waveform diagram of each phase. We can also make selections here. After clicking the front and turning gray, is to cancel the waveform of this phase. It can be combined, or display single phase display, or all of them. UA, UB, UC, IB, IC. It can be based on our own needs, to make various combinations. And we can take screenshots on this screen. After the screenshot, the instrument saves the current screen in the form of a picture. There's a screenshot at the bottom of the screen. You can click the screenshot. Save the current screen as a picture. Vector analysis is the vector phase display for each phase voltage and current. We can now see here. What should be normal is UAUB UC IAIB IC. We are now UAIUB IC UC IB. It means that the B phase current and C phase current, their phase are wrong. We can revise it. It's correct like this. Vector graphics can also be used for vector analysis. For both 3-phase 3-wire, 3-phase 4-wire, can check for this kind of wrong wiring. CT variable ratio test screen is for low voltage current transformer. We can use a big pair of pliers and a small pair of pliers to test the ratio of low voltage current transformers. According to the prompt, use a plier to plug into the C phase port of the instrument. Small pliers are used to a phase port to obtain the primary current and secondary current. In this way, check the actual ratio of the low voltage current transformer. Historical records. If we do a save operation in the test interface, we can see the history here. The record can be displayed one by one. Click to open file. Here, we can check it according to the file name we saved. Sudden rise and fall occur during the testing process. If there is a sudden rise and fall event, we will have a record here, the total number of records, the current record and the time of the event. When an abnormal event occurs, the instrument will automatically store it. The disk lookup is the condition of the internal storage of our instrument. Next, we will introduce the experiment we are doing on site. To perform data storage operations, look here, it is the record data. Here have start to record and stop record. Our current state is stop recording. Stop recording, that is to say, I don't record these situations at the scene. It's just a real-time on-site view. Let's say we want to do data analytics and generate this electric quality report in the future. Then we should choose save and let the instrument store the result as a file. The recording interval can be set artificially. It can be 5 seconds, 10 seconds or whatever time to store a set of data. Here, the default is 5 seconds. Then start recording. Before we click to start recording, be sure to enter a file name based on our test points to facilitate subsequent search, so as to avoid confusion due to too much data after a long time usage. After checking the electrical parameters and the voltage circuits of each phase are normal, we can click the start recording button. Okay, now we start recording. The file name is set as O1, bin by me. In this disk recording, you can find O1 bin. It's our currently saved file. If we're going to use software to analyze the data, our test records here must be at least 30 records. Of course, when we want to check the actual harmonic content of a line, the storage time must be a little longer, to reflect a real electricity usage. Then we can store the data. When we finished the experiment, be sure to click here to stop recording, so as to ensure that this file has real and valid data from the first to the last item stored in it. If we dismantle the voltage and current line under the condition of starting recording and end the test, the instrument will still store data. Then in the following data, the voltage and current are both 0. Then these are invalid data. So in order to avoid this situation, I click on stop recording before the test ends. Then remove the voltage and current on site. For a test process of 3-phase for wire, we have completed the introduction. Now let me introduce the on-site wiring of the 3-phase 3 wire. When 3-phase 3 wire, there is no N-phase voltage terminal. Connect the B-phase voltage on the secondary side of the voltage transformer on site to the black terminal of the instrument, because 3-phase 3 wire means no N-phase. And that voltage is 2 sets of UOB and up. Current pliers use IA and IC. IA and IC 2 current pliers. It is also clipped on the secondary side of the current transformer. The same principle. The operation process is the same. 3-phase 3 wire is selected here. Then PD turn ratio, CD ratio according to our actual situation. Because we are getting the voltage and current on the secondary side, then the voltage turn ratio is input according to the turn ratio of the field line. The current is the same. If it is a 300:5 current transformer ratio, then 300:5, then enter 60. The rated voltage is the high voltage lines. For example, for the 10 kV line measured, choose 10 kV. Short circuit capacity, the power supply capacity and the agreement capacity are also set according to the actual situation on site. If we finish testing one route, we switch to another route. We must change the file name. Is to ensure that each of our file names corresponds to each test point. After all these settings are done, we should first check the voltage and current. After the voltage and current are checked, they are all normal. We return to the parameter settings. Click Start Recording here, so that the instrument starts to store files. After storing the file, we can see the stored files in disk management. After we complete all tests, click Stop Recording here, disconnect the voltage and current. Then we can use a USB drive. Export the data we store. After inserting the USB drive, there will be a USB drive icon here, and we click here. Click Export Records, which copies all the data we have stored, and the data of each file name, to the USB drive. Then we installed our dedicated analysis software on the computer. Then use the USB drive to store the data. To the computer, use the dedicated software to analyze the data, to conduct software analysis, and generate reports, and print the report of power quality. That's all for the on-site use of the instrument.
Thanks for watching the tutorial video prepared by HD Yoga Manufacturing.